61A is an introduction to computer science. So what's that? Well, computer science is the study of the most flexible machine ever created, the computing machine. And computer scientists worry about three things. What problems can be solved using computation? How to solve those problems? And what techniques lead to effective solutions, so that by solving these problems we can actually improve the world around us. Now it turns out that there are lots of different problems that can be addressed with computation. And so we'll look at some of that list. Most people who call themselves computer scientists specialize in a particular area, which is a group of different problems. So some people study systems, which is the study of large systems, like the operating system on your computer, or the whole Facebook social network. Artificial intelligence is the study of how to get computers to do things that living things are good at, like recognizing faces in photographs. Graphics makes beautiful movies and video games. Security makes sure that you can go about your business on the internet without the NSA snooping around. And all of these other fields deal with other problems that arise when you try to apply computing to solve the world's problems. But it's worse. There's actually, within each subfield of computer science, many different subfields. So within artificial intelligence, some people study decision making. The best chess player, the best checkers player, the best Scrabble player in the world are all computers. Robotics is about building self-driving cars and robots that can fold your laundry for you. Natural language processing is the study of how to get computers to work with natural languages, such as English or Chinese. And each subfield has its own subfields. So one thing you might do in natural language processing is automatically translate from one language to another. Or answer questions. The best Jeopardy player in the world is a computer. I bring up translation because that's what I do. For the last 4 years, I've been a research scientist at Google working on Google Translate. So if you're interested in that, come chat with me sometime. And at the very end of the course, I'll tell you a little bit more about natural language processing. But the point of me showing you all of this is to show you that there's lots of different things that computer scientists do, because there are so many different problems that we want to solve. How are we going to teach a course about all those things together? Well, it turns out that all computer scientists have a common enemy to bring us all together. And that common enemy is called complexity. So this course is really about managing complexity. And there is one weapon that is more important than any other in our battle against complexity, and that's called abstraction. So abstraction is this wonderful idea that is something that you do all the time already. It's when you take a complex system, but think of it as just one whole thing. Give it a name, and don't worry about all of its details. So you might say, oh, John is my instructor for this course. Now, John is actually some clothing covering up some skin, covering up some muscle, covering up some bones. Now, there's more to it than that. If I want to live, I need all these different organs working in harmony, coordinated by my nervous system, in order to keep everything functioning. And all of that is apparently just a bunch of water and carbon and nitrogen in there. I mean, it's just unbelievably complex what a human being is. But you just call me John, and you talk about what I'm teaching without worrying about exactly how many carbon atoms are inside my body. That's a form of abstraction. And we want to learn how to use that same idea of abstraction when we create computer programs. The course is also about programming paradigms. So these are broad ideas of how to organize whole programs in order to take advantage of our abstractions. It's not all about the low-level details of what a computer is doing to manipulate zeros and ones. That's a common misconception about computer science. But we don't just sit around and stare at screens like the Matrix all day. Instead, what we do is express ideas in programming languages, hopefully in ways that other people can understand. The programming language that we'll use in this course is called Python. So you'll be joining a community of 1 million other people who also know some Python. But we do learn it in a little bit different way than most in this course. Instead of rushing through lots of different features quickly, we are going to work through details very carefully to understand how they correspond to the big ideas in computer science. And we want to develop a full and deep understanding of the language fundamentals. We're going to learn by implementing stuff, building big projects. In fact, the projects in this course are just bigger than most projects taught in introductory computer science classes. And finally, we're going to learn how it is that computers interpret programming languages. So computers aren't magic, although they do magical things for us sometimes. We can't actually understand exactly how they go from a description, a program, to the behavior that they exhibit. And we're going to look at that in detail. Now, this is a lot to cover in one semester. So this is a challenging course. It takes many students 15 hours a week or more in order to complete all of the work. So I'm aware that it demands a lot of you. I think all this stuff is just extremely important, which is why I ask so much. But you should be aware that if you stick around, and I really hope you do, that there's quite a bit of work ahead. But I hope that work will be rewarding.